All right, for some of you, this video may seem basic. For others, it might not seem so basic, all right? Depends on your skills. You may find certain problems easy, certain problems difficult. All of this, okay, is going to utilize what we learned in the last lesson, properties of quadrilaterals, all right? So what we're going to be doing in this lesson are numerical examples. Numerical practice with quadrilaterals. And hopefully all this practice, because the next lesson will be algebra, hopefully all this practice will help you to get the properties down. All right, so here's the first example. Let's say the area of a square is 36 square inches. What is the perimeter? So area is side squared. Most of you are going to say length times width. But we have 36, right, equaling side squared. If you made it length times width, how exactly do you plan on solving that? Okay, you'd have to turn either the length into the width or the width into the length, which is the same as saying side squared is 36. So therefore, the side is the square root of 36, which is 6. Normally, when we solve an equation like this, we say plus or minus the square root, but not when we're dealing with length. When we're dealing with length, the length has to be positive. So now the perimeter of a rectangle is 4 times s. So that means the perimeter would be 4 times 6, or 24 inches. Perimeter is linear. Area is squared units. Okay, one angle of a parallelogram is, we'll make it 65 degrees. Find the other 3 angles. Okay, I think it's best if you try to draw this. Just think 65 degrees is a little bit more than 60. So start off as if you're drawing an equilateral triangle, right? Then turn it into a parallelogram. It helps to draw pictures for most of these questions. So I'm going to make this 65 degrees. Well, look at the properties of a parallelogram. Opposite angles are congruent. Consecutive angles are supplementary. So 180 minus 65 degrees is 115 degrees. And you can check it by adding all of these together. And they should be adding to 360 degrees, which they do, because 115 plus 115 is 230. 65 and 65 is 130, and when you add 130 and 230, you get 360. So that's just a built-in check. Okay, let's take a look at another example. Okay, I'm going to give you the length and the width of a rectangle. Okay, the length of a rectangle . We'll make it 5 inches. And the width is 12 inches. What are the lengths of the diagonals? So think about it. This is 5, this is 12. Let me just draw this diagonal. You have a right triangle. Now, if you have the 5, 12, 13 triple memorized, then the answer is just 13. Okay, if not, you would have to do leg squared plus leg squared equals hypotenuse squared. Add those together, and then get the square root, which is indeed 13. The other diagonal must be the same, because in a rectangle, the diagonals are congruent. Okay, therefore, they are both 13 inches. Okay, pause and copy down the next problem. The diagonals of a rhombus are 16 and 30. Find the perimeter. So, my picture is not going to be drawn to scale. But, let's say this is 30. Let me color code it, right? And then, let's say this diagonal is 16. Well, a rhombus is a parallelogram, and in a parallelogram, the diagonals bisect one another. So that means this is 8, and that means this is 15. Now, in a rhombus, not only do the diagonals bisect one another, because a rhombus is a parallelogram, but the diagonals are perpendicular. So that means you have a right angle here. Okay, so I can find this side. When I find the side, I can either memorize 8, 15, 17. So therefore it's 17. If you don't have that triple memorized, then you have to do leg squared plus leg squared is hypotenuse squared. Okay, you have a calculator, so do all this on a calculator. All right, little dinosaur me just is going to do it in her head, okay? Because I've done it enough times without a calculator. All right, so I get 17. So the next thing is, in a rhombus, all four sides are congruent. Look at all the geometry that's involved here to get the problems done. So you do 4 times 17, which is 68 inches. So that would be your perimeter. There you have it. Okay, quite a bit of thinking involved. But despite common belief, you can be trained to do these problems. Once you see certain math problems, the next time you see them, you have an advantage over someone who has never seen a problem worked out of that sort, okay? That's the reality. Let's take a look at number 5. Okay, so I'm going to, in number 5, I'm going to introduce a word. Okay, it's called the median of a trapezoid. Some people will refer to it as the mid-segment or the mid-line. That's like from a blast in the past from my generation. All right, anyway, so I'm going to give you a trapezoid. Okay, I didn't do this in the last video because I thought there was plenty already. So here's what you need to know. A median, just like when you think of it as a mid-segment, it's going to pass through the midpoint, okay, of these sides. Now, there's a formula. Let me call this A, let me call this B, and let me call this C. Okay, so C is going to be A plus B divided by 2. You just need to memorize that. Okay, so for example, let's say I give you, okay, I tell you that this is that this segment, let me call this A, B, C, D, E, F. So we tell you that EF is a median. Okay, in trapezoid, A, B, C, D, right? And then I tell you, well, okay, let's have you work backwards so we don't make it too easy. Let's say EF is 35 and we'll say DC is 55, and we want to find AB. So the formula that I gave you above would be that EF is DC plus AB divided by 2. So then it stands to reason that 2 times EF would equal the sum of DC and AB, right? So 2 times 35 would equal 55 plus X. So that's 70. 55 plus X, subtract 55 from both sides. And so you get 15 is X. So that's some new vocab for you on this topic. Okay, let's take a look at another parallelogram problem. So we're given this parallelogram below, MNKL, with diagonals MK and NL. Angle 1 represents angle MLN. Angle 2 represents angle NLK. So let's say that we tell you, okay, the measure of angle 1 is 48 degrees. And then we tell you the measure of angle NKL. All right, we'll make that, I don't know, 110 degrees, okay? Find the measure of angle 2. So you got to be smart here. You have to think about the consecutive angles. Okay, in a parallelogram, the consecutive angles are supplementary. Consecutive angles are supplementary. Okay, so therefore, the measure of angle NKL plus the measure of angle MLK is 180. But we already know that this is 110. So therefore, the measure of angle MLK is equal to 180 minus 110, which is 70 degrees. Okay, but now I know that angle 1 is 48, guys. Okay, we call these angle chaser problems. So if angle 1 is 48 and angle MLK is 70, the measure of angle 2 is 70 minus 48 degrees. So that would be 22 degrees. So you're going to have to do a lot of thinking here. You're really going to have to be fluid with your properties in order to do these questions. Okay, let's take a look at a few more. All right, I don't want to make this video too long. But a lot of this comes from experience from the middle school as well, all right? Let's do one with a square. Okay, so in the last video, I said sometimes there could be hidden special right triangles. Okay, so I have a square, okay, with a diagonal measuring, okay, I'll be nice to you, 7 rad 2. Get the perimeter. Or I could say get the area. How's that? Get the area. Why not, right? Doesn't matter. So if you have a square and you have a diagonal that measures 7 rad 2, look at what you have hidden in this picture. A 45, 45, 90 right triangle. So if the diagonal is 7 rad 2, that's the hypotenuse. To get a leg, remember from the last unit, you have to do 7 rad 2 divided by rad 2, which is 7. Okay, so then we get the area, which is 7 squared, which is 49. Okay, so here's the thing. You wouldn't be able to do this math without the geometry. This is one of the amazing things about geometry. Okay, so we're given this rhombus span, and we're given the measure of angle P, right? And so I want to find, I don't know why I have the word and here. Oh yeah, I wanted to say and diagonal. All right, and, oops, and diagonal SA is drawn, okay? Find the measure of angle MAS. All right, so you have to know your properties of angles of a rhombus. Well, number one, a rhombus is a parallelogram, so consecutive angles, right, are supplementary. So that means the measure of angle P plus the measure of angle PAM is 180. So 84 plus the measure of angle PAM is 180. 180 minus 84 is 96, okay? Measure of angle PAM is 96 degrees. Now I want mass. This is what I want. Well, in a rhombus, okay, in a rhombus, the diagonals bisect the angles. Okay, therefore, the measure of angle MAS is half the measure of angle PAM, which is half of 96, which is 48 degrees. Okay, so good luck figuring that out if you don't know the properties of a rhombus, right? You get what I'm trying to get you to buy into here? All right, so I don't want to belabor this topic. Okay, we will be working on this in class. And I hope that this video is, has helped you to start to get to see why you have to buy into learning the properties of a quadrilateral. Besides that, you're going to need them to do all the proofs we're going to be doing. Okay, because the fact of the matter is, maybe you don't have an interest in proofs. You're not going to have proofs when you take the ACT. But you are going to have questions like this. So either way, you have to know the properties, kids. Can't get out of them. See you in class. Bye.